You have an expression that says rationalize the following: 2 all over root 3, 5 over 3 minus root 2, root 3 all over 2 minus root 3. Now, how are you going to rationalize these sort problems? Firstly, we would understand what rationalization is. Then, knowing what rationalization is, have solved half of the problem. What is rationalization? Rationalization is the process whereby we remove the irrational numbers in square roots from the denominator. The irrational numbers in form of a square form in a square root that are found in the denominator of expressions, surd expressions are known as rationalization. Then through this rationalization, we will remove all those numbers by multiplying both the numerator and the denominator by its conjugate. Let me take it again. Rationalization is the process whereby you see all these individual surd numbers that are found in the denominator, we remove them. We don't actually need them. So that process whereby we remove it is called rationalization. And we can remove that by multiplying both the numerator and the denominator by the conjugate of the values found in the denominator. Now you might ask, what is a conjugate? Okay, let's say we have an expression that says root 2 plus root 3, and we have root 5 minus root 2, and we are being told to find the conjugate of this. Conjugate of a given value is the opposite to the sign which that expression has. This expression has a plus sign. The conjugate of this expression would actually be root 2 minus root 3. That is the opposite of the actual sign. Now, this also would actually be root 5 plus root 2. So, we're taking it back to the definition as I said in factorization, which we factorize a given expression by multiplying both the numerator and the denominator by its conjugate. We have this expression. So let's just move further to solution to these problems, then we would understand more on this. We have our first problem here, which is 2 root 3. 2 divided by root 3 would actually be done by 2 root 3 multiplied by root 3 all over root 3. So this one doesn't have any sign that is attached to it, but we would multiply both the numerator and the denominator with this same value, with this same number that we have in the original denominator. So multiplying this, we would have 2 brackets root 3 all over root 3 multiplied by root 3. So 2 multiplied by root 3 would actually leave us with 2 root 3. Root 3 multiplied by root 3 would actually leave us with 3 as an answer. So this is the final answer to this question. We have rationalized this, and at the end of this problem, we have removed this root form that is in the denominator. So rationalization is a process whereby at the end of a given problem, we tend to remove that surd value that is in the denominator. So let's move to problem number B, where we have 5 root 3 multiplied by root 2. Now, the application of the conjugate is involved in this expression, where we have minus sign. So this would actually be 5 over 3 minus root 2 multiplied by 3 plus root 2 divided by 3 plus root 2. So what would we actually get? We would multiply this to this, multiply this to this. We will have 5 bracket 3 plus root 2 all over 3 root 2, 3 root 2. So this is what we actually get when we divide, when we multiply this to this. Proceeding, we would now have 5 multiplied by 3 would actually give us 15 plus 5 multiplied by root 2 would actually give us 5 root 2. So remember also in surd problems, any given value that is not inside the root form cannot multiply a number that is in a root form. On a normal basis, 5 multiplied by 2 is 10. But due to in surd multiplication, when this given number is not in a root form, it stays outside the root form value. So we have 5 root 2. Then we have on the denominator an identical number, 3 root 2, 3 root 2. Let's just keep these signs at a place. Now, having these identical numbers, what are we actually going to do? We will square them up. We will square this up and we will square this up. So 3 squared minus plus will actually give us minus 2 root in a square form. Now 3 squared, okay, let's proceed. 15 plus 5 root 2. 3 squared would actually give us 9. Squared square root of this would actually give us 2 as an answer, because it's actually telling us that 2 squared multiplied by 2 squared, which is actually 2. In the first video which I made, I explained the rules that are guiding sort from where we have root a multiplied by root a would actually give us a. So this is actually this. So we have 2 as our answer. Now 15 plus root 5 all over 9 minus 2 is actually 7. So this is the final answer to this expression. We have factorized, we have rationalized this given number. We have 5 roots, 5 all over 3 minus root 2. And at the end of this problem, we see we have removed this root value at the denominator. It's no longer in the denominator again. As we earlier explained, that rationalization is a process where we removed that surd value that is in the denominator. We don't actually need that. Now let's see our last expression here, where we have root 3 divided by 2 minus root 3. That will be root 3 which would actually leave us with root 3 divided by 2 minus root 3 multiplied by 2 plus root 3 divided by 2 plus root 3. We will have 3 bracket 2 plus root 3 divided by 2 minus root 3, 2 plus root 3. So, remember as I said earlier, any given value that is inside a surd form cannot directly multiply another value that is not in a surd form. So this multiplied by this would actually leave us with 2 root 3. Root 3 multiplied by root 3 would leave us with 3 divided by 2 squared, which we have this multiplied by this will give us 2 squared. This to this will actually give us minus 3 squared. Minus 3 actually, sorry. So we would actually obtain 2 root 3 plus 3 divided by 4 minus 3, which our final answer is 2 root 3 plus 3. So we have understood what rationalization of surd is. It's a process where at the end of the solution we would have an answer that doesn't have any surd value in the denominator again. So friends, if you actually found this video interesting, please click to my subscription button. You can also drop your comment down on the comment section. Thank you so much.